This one graph can tell you velocity, acceleration, and even displacement, but most students only understand just one part of it. Let me show you something. Imagine a car starting from rest, then speeding up, and suddenly slowing down. Now here's the question. How do we represent all of that on a single graph? That's exactly what a velocity time graph does. But here's where it gets interesting. The slope of this graph gives acceleration, and the area under the graph gives displacement. Yes, area under the graph equals displacement. And once you understand this properly, you can solve most motion problems in seconds. So in this video, we'll break it down step by step, with simple visuals and zero confusion. Let us understand velocity time graph of a body moving with constant velocity or no acceleration. Guess the nature of velocity time graph of a lady cycling at a constant velocity of 20 meters per second. Yes, that will be a straight line parallel to time axis. The graph shows constant velocity of 20 meters per second. What do you think will be the nature of velocity time graph of a body with uniform acceleration? The graph will be a straight line as shown. The graph originates from 0 if the body is initially at rest. The slope of the graph in this case is positive. Guess. What information is hidden in the slope of velocity time graph of uniform acceleration? Let the body under uniform acceleration moves from the position A, where velocity v1 was 20 meters per second at 4 seconds, to position B, where the velocity v2 is 40 meters per second at 8 seconds. Final velocity v2 equals 40 meters per second. Final time t2 equals 8 seconds. Initial velocity v1 equals 20 meters per second. Initial time t1 equals 4 seconds. Therefore, the slope is v2 minus v1 over t2 minus t1, which equals 5 meter per second square. Look at the unit. It is meter per second square, which is the unit of acceleration. Also, the slope is positive. What will be the nature of the graph for uniform retardation? The velocity time graph will be a straight line with negative slope. Here, the velocity gradually decreases, as is evident from the velocity time graph. Can you find the slope of velocity-time graph of uniform retardation? Let the body under uniform retardation moves from the position A, where velocity v1 was 30 meters per second at 4 seconds, to position B, where the velocity v2 is 10 meters per second at 8 seconds. Let us find the slope and analyze. Final velocity v2 equals 40 meters per second. Final time t2 equals 8 seconds. Initial velocity v1 equals 20 meters per second. Initial time t1 equals 4 seconds. Slope is v2 minus v1 over t2 minus t1 equals minus 5 meters per second square. Look what we see. The slope is negative. Can you guess the nature of velocity-time graph for non-uniform acceleration? Look at the cyclist, moving sometimes fast, sometimes even faster, with non-uniform acceleration. Obviously, the velocity-time graph will be a curve.
Do you know that you can find acceleration at different instants from the slopes at different instants in non-uniform motion? Let us take an example. Let the body changes its position from A to B. A tangent is drawn at A to find the velocity at A. Projections are made to the velocity axis from either end of the tangent to find the change in velocity. Therefore, the change in velocity is 20 meters per second minus 4 meters per second is equal to 16 meters per second. Similarly, projections in time axis gives the time taken, that is, 8 seconds minus 4 seconds is equal to 4 seconds. Therefore, acceleration at A is velocity divided by time is equal to 16 meters per second divided by 4 seconds is equal to 4 meters per second square. Similarly, acceleration at B is 13 meters per second square. So, we can find acceleration at different instants from the velocity time graph of non-uniform acceleration.
Do you know that area under velocity time graph is displacement? Let us understand with an example. What is the displacement of a body moving in uniform acceleration between the time instants of 4 seconds and 8 seconds? The answer is displacement equals area under the graph between time instants 4 seconds and 8 seconds, equals area of the triangle ABC plus area of the rectangle ACED that makes 120 meters.